Okay, good afternoon again. So we're going to discuss the new topic. This is from section 2.5. It's about optimization. Our job here, I also uploaded some videos on Molima from Khan Academy for practice, but we'll go through an example here. Our job is to find the dimensions of an open box with a square base that has a volume of 200 cubic inches and least surface area. So over here, if you notice, what we did is we drew a box that has a volume, box with a square base. That means the length of the base is x, and it's the same as the width of the base. It also has another dimension, a height. All those are unknown at this point. What we do know, however, is that its volume is given as 200 cubic inches. Okay, so the formula for the surface area is this is literally just counting up the area of all these sides. So 200 cubic inches. It's an open box, so it doesn't have a top, it has a bottom. The area of the bottom is x squared, and the four sides, front, back, left, and right, each have an area of x times h. So what is our job? Our job is to minimize this function. Now this is a function of x and h, but with this constraint, x squared times h is equal to 200, we can make it a function of x only. And how we do this, we can solve for h. What is h in terms of x? It's 200 over x squared. So what do we get here? A is equal to what? It's equal to x squared plus 800, right? 4 times 200 is 800 times x divided by x squared. We're going to call this a of x. Now, it turns to a job of minimizing this function. We know how to find the local minima, and we can determine from the graph whether or not that local minimum is an absolute minimum just by graphing the function. So to do that, let's differentiate this. To differentiate this function, of course, we're going to simplify. It's going to be x squared plus 800 divided by x is equal to x squared plus 800 times x to the negative 1. What's the derivative of the function? What's the derivative of the function a of x? It is two x minus 800 times x to the negative 2. So we're going to set this equal to 0. And if we notice, okay, what happens? Okay, well, okay, so what happens when we set this equal to 0? We end up with, we can solve this for x, we end up with 2x equals 800 over x squared, or x cubed is equal to 100. So that means x is equal to cubed root of 400. So you don't have to worry too much about this. Is exactly if you want, you punch it into your calculator, find what that is approximately. But what's important is that we took the derivative, set it equal to 0, and solve for the critical number. So the point is, translated this word problem, blah, 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 to a math problem where our job is just to minimize this function. This is just a function of x. Our job is to minimize it. We know how to do that from the tools of differentiation we learned earlier. So now we're at this stage. Cube root of 400. What happens to the left? Okay, well, x is 2x. So if we plug in, actually, if we first just plug in square root of 400, let's see what's going on. Well, notice here, what's the function doing? It is going to be, pick your favorite number less than this, let's just say 1. That's going to be less than cube root of 400. This is 2 minus 800 over 1. Well, that's negative. 2 minus 800 is a negative number. Pick something larger than it. Let's just say 500. So this is something large. 800 over something very large. 500 squared. Well, this is less than 1 then. 1,000 minus something less than 1 is going to be positive. So this is positive. So that means if we graph the function, what happens? The function, it goes from decreasing to increasing. So we did have a minimum, whatever this value is, minimum. So the point is, okay, went from decreasing to increasing. Now, how do we know this is an absolute minimum? Well, the function isn't doing anything else, right? It's going from decreasing to increasing. There's really no other place that it could, this is the absolute minimum value because there's no other place. If it had another minimum, even a local minimum, it would have to change somewhere else as a continuous function from increasing to decreasing. The only other possibility maybe is on the left side of the x-axis, but there, notice x is negative. That wouldn't make physical sense. You couldn't have the dimensions of a box could not have a square base with a dimension that was negative. Its length could not be negative. Length has to be a positive number. Okay, so we're almost done. Now we just say, okay, our x, the length of the base, has to be length of base x. What's the length of base x? It has to be cube root of 400. Height, therefore, is 200 over 400 to the 2/3. Okay, so you're welcome to plug this in to a calculator, see what you get. Notice this is, so not exactly sure what that is, but you can find what that is when you plug in the calculator. dimensions work out a little better here. Let's say this was cube root of, say, 8, then it would be 2, and this would be, say 200 over 2, which would be, which would just be 300. Okay, in any case, what's most important is that we plug back in our critical number and solve for the height.